Hi, I'm Philip Resnick from the University of Maryland. Before we get started, I want to note that some of the things we'll be talking about in this talk can be challenging. And if you or somebody that you care about is having difficulty, feeling hopeless, feeling in a crisis, there are resources that you can reach out to, and some of them are on this slide. So to start with, I want to situate mental health within the broader context of healthcare. One thing that a lot of people don't realize is that mental health is every bit as much of a problem as pretty much anything else we face in healthcare. In purely economic terms, mental illness in terms of its global worldwide cost is right up there with cardiovascular diseases, and it's more than diabetes and chronic respiratory diseases and cancer combined. What makes it worse in the US is that even if you are somebody who knows you are having a problem and you want to get help, a third of the population in the United States lives in an area that's been federally designated as not having enough mental health care providers. Suicide in 2016 became the second leading cause of death for young people in the US between the ages of 10 and 34. And in fact, in the US, suicide is quite a lot more prevalent than homicide. If you think about the problems that clinicians face, one way to look at it is as a sequence of things that happens. You have what I'll call screening, which is trying to identify that somebody has a problem that needs to be dealt with in the first place. Second is assessment, trying to figure out what the problem is, how severe it is. Then you have intervention, treatment. And finally, when somebody is in treatment or therapy of some kind, you have monitoring in order to keep track of their condition and see if they're still okay, see if they're going downhill, and so forth. Now, these are really hard problems, even for clinicians. A small subset of the problems they face. One is that a lot of the interaction they have takes the form of a structured interview. And when you are doing that, you are drawing on your training, and that may involve very different theories or underlying paradigms. There is not necessarily a standard approach to every problem. Second, clinicians are often going on instinct, not just the data or aspects of the clinical training. The clinical training. And so this introduces potentially the risk of bias. For example, when a clinician might be dealing with somebody who is not from their own, say, socioeconomic group or racial category, or from some other community that they're less familiar with. And this really comes out when clinicians have to deal with people from a specialized population of some kind. Many clinicians don't have the specialized training to deal with, for example, military veterans or people with drug addictions and so forth. One of the biggest problems that clinicians have is that they have a limited window into what's going on with the patient. They have these clinical visits. And if you think about it, a typical psychiatric visit, these are perhaps regular, perhaps few or far between. And you've got often 15 minutes that are devoted primarily to managing somebody's medications. There's an enormous amount of the lived experience of a patient that clinicians simply have no access to. And the problems are more complicated today in the shadow of the COVID-19 pandemic. Clinicians have expressed concerns about a mental health tsunami, about an echo pandemic that's coming about as a result of things like social isolation and financial burden and stress. Now, there is an enormous amount of potential for technology to help. Franklin and colleagues did a meta-analysis where they looked at the research on suicidal thoughts and behaviors using traditional methods for studying the problem and trying to understand what factors put people at risk. And what they discovered is that the ability to predict suicidal thoughts and behaviors had not improved over the space of 50 years of research. Looking at their data, they came to the conclusion that the current state of things suggested a shift from the traditional risk factor-based methods to taking a data-driven machine learning approach to the problem. So one way of looking at this is thinking about suicide as a binary prediction problem. one would like to separate users who will go on to make an attempt from users who don't. And by users, by the way, I am foreshadowing the idea that we're going to be looking at, for example, social media evidence as opposed to simply things in a clinical setting. A very nice paper on this topic is written by Glenn Coppersmith and colleagues in 2018. At the left here, you see a performance curve, an ROC curve, for a bunch of predictive models that they developed on predicting a suicide attempt or not, the binary classification problem, from somebody's social media evidence. The diagonal line is chance performance, and perfect is up and to the left. And you can see you're getting some pretty strong performance here. In fact, in their analysis, they looked at a theoretical population of 1,000 individuals. They extrapolated their results into the statistics of a real-world setting where you had a typical prevalence of people's likelihood of making a suicide attempt. 40 to 60% of the people that the model predicted would go on to make a suicide attempt did. In contrast, if you look at the typical performance of clinicians trying to make the same prediction, a typical clinician, in their judgments, 4 to 6% of the people that they predict will go on to a suicide attempt actually go on to do so. And so the message here is clear. These machine learning models actually may not be perfect, but they have an enormous amount of valuable possibility, potential information in them. And it's not just the binary classification problem. It's also about understanding what's going on with people and characterizing that in ways that clinicians can understand. So here, for example, is an essay written by a college student about coming to college. And a typical machine learning approach will identify useful features for, say, a binary classification problem. I put them in bold here. But you can also take a more nuanced approach. Colleagues and I used a kind of technology called a topic model in order to automatically, in an unsupervised way, for the language, but then with some supervision related to personality. I'll get to that in a second. We used these techniques to, in some sense, evoke or discover themes in the language that people were using in these college essays. So for example, in blue here, you see language that's related to social isolation. I don't want to go to class or leave my room or talk to people. The things in red are related to vegetative symptoms, that is, energy level. The things in green are related to anhedonia, that is, being unable to enjoy things that you used to enjoy. In an analysis that we did, we looked at a large set of these kinds of essays and looked at the kinds of themes, which you can kind of think of as very much like word clusters, that came out of this. So you have one row per topic or theme that was discovered. And we looked at these using a model that related a person's language to their score for neuroticism on a standard personality inventory. And what we found was, for example, that in the themes or topics that were not associated with neuroticism, you tended to find things like going to sports, listening to music, going to parties, things that are indicative of social engagement of people in this population. In things that were more positively associated with neuroticism, which is, by the way, often comorbid with depression, and that was the context of this, trying to find things that might be relevant for looking at depression, you have those energy-related things, like sleep and getting tired. But you also see this being expressed through what was automatically discovered in the data in ways that are specific to the college population. Right? I mean, you wouldn't expect that other populations would necessarily express a lack of energy level in terms of things like being late for class or falling asleep in class or taking naps. But that's what you see in a college population. The same kinds of techniques can be applied to other populations in order to look at things that are more specific to them. And of course, a similar thing goes on here where you see a topic showing up that's about anxiety, stress, nervousness, and not surprisingly for this population, you see things like tests and studying and feeling anxious and having a hard time focusing. Now, what I've said so far is that there are some real opportunities for progress because there is useful signal in people's language. but progress depends on actually having the data to work with. And that can be a real challenge. In a clinical setting, HIPAA and privacy considerations can make it very difficult to actually get relevant data related to mental health and healthcare in general. In addition, that data alone doesn't give you much more than a limited window into what's going on in people's lives. So I'm going to use a term that Coppersmith introduced, the clinical white space, in order to describe other kinds of data that are available to us, that didn't used to be available to us. What computational social scientists sometimes call the digital traces of people's lived experiences. What you have here at the top in the little red lines are one individual's healthcare interactions, 5 of them over the course of a year. The blue lines are their social media posts over the same time period. So you can see the term clinical white space is really evocative. You literally have the white space between the healthcare encounters where there's an enormous amount of information, and it's social media. So it's information in the form of language to a great extent. And that's incredibly useful information to have in a mental health setting. Now, of course, there are privacy issues, ethical issues, technical issues in being able to obtain and work with those kinds of data. What Coppersmith and colleagues have done is set up a data donation platform called ourdatahelps.org. And that is a platform that enables anybody to go and donate their data for research, primarily people who have survived a suicide attempt and want to donate their data to help others. You can also have people who have loved ones who have died by suicide, donating the data of the loved ones. You can also have people who have never had a connection with suicide, donating their data anyway, because of course you need people across all ranges of the mental health spectrum in order to do machine learning and better understand what's going on with people. We at the University of Maryland have taken that a step further, collaborating with Coppersmith and his organization. They have ourdatahelps.org. In collaboration with them, we've created umd.ourdatahelps.org. And in collaboration with Deanna Kelly at University of Maryland's Medical School, and Carol S.B. Wilson and John Dickerson at University of Maryland College Park, where I am, we have a project going on where we are doing a similar kind of ethical, careful, consented data collection for people who may be suffering from schizophrenia and depression. So there are frameworks that make it possible to collect data in an ethical, appropriate way in order to do this kind of work. Now, how do we make progress within natural language processing and AI more generally? Something that I think has been borne out literally over decades is that the way you make progress is by getting an entire community of people in the research field to collaborate on the same problems on the same data sets. And this falls within a category that sometimes is referred to as a shared task. You have some data set, organizers of an activity, a shared task activity, make it available, define the specifics of the problem that one might be trying to solve. For example, it might be predicting the depression rating of an individual, or predicting suicide attempts, or predicting a level of suicide risk. In typical cases, these are predictive modeling problems where you use supervised learning in order to train on a data set that has the correct or ground truth answers for individuals, and then you test on a held out or previously unseen data set of individuals and evaluate. So that's what you see here. You identify a data set that people are going to use in common. You define the task. You get a bunch of teams to participate using different kinds of approaches. You get the data out to them. You then get test data out to them to evaluate on. You evaluate and see how they did. And then you have a conversation. You have a workshop, a conference, getting people together to talk about what worked well, what worked not well, and what you should do next. Now, you may notice something here. This idea of distributing data is a real problem. From a privacy point of view, this is one of the enormous problems in healthcare in general, and certainly in mental health as well, even with social media data, which can be quite sensitive. Simply getting data out to the research community is something that makes a lot of people nervous, and possibly justifiably so, because it introduces risk. And so how do we solve that problem? That's a problem that's really been holding the field back. Well, one approach that has recently been explored is the idea of a secure data enclave. A number of people have been exploring variations on this theme in collaboration with folks at NORC at the University of Chicago. That's a nonprofit research organization. I have been working to help them develop a secure data enclave where the idea is you bring the researchers to the data rather than vice versa. There is a secure environment where the data live and the researchers come there and the data can't get out. And so we've actually been in the process of doing that for a shared task specifically focused on prediction of suicide risk as a part of a workshop called the Workshop on Computational Linguistics and Clinical Psychology that is a part of the North American Association for Computational Linguistics conference in 2021. The way that this enclave works is teams can go to a login page with secure login credentials, come into the enclave to a secure desktop, a virtual desktop that doesn't let data out. In fact, it doesn't even let them copy and paste from inside and outside the desktop. And from there, they can then go to an AWS-backed environment where they have the full arsenal of natural language processing and machine learning tools and can work on the data in this secure environment in order to develop predictive models and improve the algorithms and do formative assessment of how they're doing and to do summative assessment by taking that test data they've never seen before and evaluating and seeing how their system does. And then finally, at the upper right, you have the ability to take things like results off of the enclave, but that goes through a careful process of review and governance to make sure nothing is leaving the enclave that shouldn't. That little X is showing you that this entire process is disconnected from the internet at large, except through carefully governed processes. And so we actually just completed a shared task looking at level of risk assessment for a data set of individuals who had posted on social media. And I'm not going to go through the numbers here. The take-home message is we have teams, we have numbers, we have improvements over the baseline performance that took place because people were able to do this work and improve the approaches. And we're having a workshop to discuss it and then hopefully figure out what we've learned and move the field forward. So let's suppose we're wildly successful. Suppose we have great data. And suppose this gives us great classifiers, great predictions in the case of mental health conditions, suicide attempts, and so forth. There's a question that we as technologists often don't ask, which is, then what? Right? We think about a particular abstraction of the problem. We're taking a bunch of data, we have a prediction task, we apply our techniques, we obtain predictions, we evaluate them. But of course, all of this takes place within a broader mental health ecosystem, if one were going to actually use this for something useful. And I need to remind you that a little while ago, we talked about the fact that the mental health care system is already overburdened and under-resourced. What happens in a country, in the US, for example, where you have a third of the population who would have a hard time seeing a mental health provider, even if they knew they had a problem? What happens when we start getting better at identifying that somebody might need to be seen? What happens when we increase the number of true positives? And of course, also add false positives to that as well. This suggests a shift. There are really two shifts. One that I'm not going into here is a shift from viewing this as a technological problem to viewing it as a societal problem. One of the best ways to solve the problem with under-resourced mental health care is to provide more resources for mental health care. But as technologists, we also can make progress. And one of the ways that I want to suggest we can make progress is by a shift from thinking about mental health in general and this problem of predicting whether somebody may be at risk for suicide. Going from thinking of it as a classification problem, a yes or no, to thinking of it as a kind of a prioritization problem. You have a population of individuals, and the traditional technology-centric views of the problem, which have been taken in a variety of shared tasks at that CL Psych workshop, at the Clay eRisk workshops, and other forums where people work on this. That view tends to say it's a labeling problem, yes or no, or maybe it's a stratified multiple labels, severe, moderate, low risk, no risk, and so forth, right? But that may not be enough. It doesn't take into account the realities of the world that the clinicians live in. So let's abstract what that world looks like for a second. Think about somebody I'll describe as an expert, somebody somewhere in the set of clinicians who evaluate people. They have a population of individuals who might potentially be at risk. So this is the monitoring piece from that earlier slide. I'm not talking about screening everybody. I'm talking about, let's start by looking at the problem with a population of people that you already know might be at risk. In that population, somehow you need to prioritize limited resources, such as the clinician's time. And if you have evidence coming from the kinds of techniques that I've been talking about, you may have, say, lots of social media posts. A clinician can't look at everything to help decide how much attention and when this particular patient is going to need. So you also have a nested prioritization problem, where you have to decide what is most likely the thing the clinician should look at in order to figure out what's going on with the patient. And of course, all of this has to be done within limited resources, and particularly the time of the humans in this loop. With student Han-Chin Shing and my colleague Doug Ord, we've developed a technical approach to this. It takes advantage of something from deep learning called a 3-level hierarchical attention network. And the interesting thing about this particular deep learning approach is that you may have a situation where you have a single label for an individual and also evidence from, say, multiple documents, and within that document, multiple sentences, say. And you don't have individual documents labeled like you often do in natural language processing, supervised learning problems. It's just the individual. This is an architecture that allows you to have just the label of the individual at the top and to use what you learn in training to help decide which of the documents were most responsible for the label that was predicted, and which of the sentences within the documents and words within the sentences were most responsible for what's being predicted. And this enables you to produce results at runtime, at test time, if you will, where you can take a population of previously unseen individuals, rank them. Here we've got the individuals being ranked, and then for each individual, in a nested way, rank their documents. And here you also have a heat map over the individual words that might be responsible. What you're seeing here are actual results obfuscated for privacy reasons, but actual results of the top 3 individuals in some experimentation that we did. And within the individuals, you see the documents, and then you see the heat map over the words that were most important in making the prediction that produced the ranking that this was 1, 2, and 3 in terms of suicide risk. Once you do that, you can quantify how well it is that your system is doing by imagining and, in fact, simulating a scenario where you have a clinician with limited time and simulating, estimating the amount of time things take, and then finally saying for a given time budget, how many individuals who actually are at risk, the positive instances, would they have found within that time budget? And so here's a result from Han's paper. The thing that I want to point to here is the middle column, where we simulated a time budget of 3 hours. And the numbers here are the number of individuals severely at risk in our population, in our data set, of which there were 44 severely at risk in total. How many of them would have been found by the clinician within a 3-hour time budget using different ways of processing documents and assigning rankings of individuals and rankings of documents? And what you can see here is that number at the bottom, right, of the middle column, is significantly higher than, say, the baselines we have up at the top of the column. If you use some of the more naive approaches, like use logistic regression and rank individuals using that, and then just look at their documents in reverse chronological order or forward chronological order, you can see that using a more sophisticated architecture, you can improve on the number of individuals that could have been found on average within that specific time budget. Now, there's another interesting approach to prioritization that colleagues and I have been working with. There is a colleague of mine named John Dickerson at the University of Maryland, and this comes about because I went to a talk that he gave that had nothing to do with mental health. He was using a machine learning approach called multi-armed bandits, and a particular development of that he and students had done called tiered multi-armed bandits, sort of a hierarchy of multi-armed bandits. And they were applying this to the problem of deciding who should get a job. And the idea here is that each stage or tier of their framework, you have successively more costly ways of gathering information that also are successively or progressively more informative. So at stage one, maybe you do something like reviewing a resume, which is relatively inexpensive. Some subset of the population then passes through to the next stage, and maybe you do, say, a remote interview. And then that's more expensive, of course. You only want another subset of those to pass on to, say, the most expensive stage, where they might do an on-site visit. And from that, you then say, okay, this is the subset that I'm going to hire. And I actually went to his talk on this topic and I said, John, and I grabbed him by the arm. This is actually quite literally grabbed him by the arm and dragged him off to coffee. And I said, you actually are solving my problem. You have a hammer, and the problem that I'm focused on looks a lot like a nail. And so we've now been collaborating on a framework where you take exactly this same kind of approach, but in a mental health setting, where the goal is to take a population and have them go through successively more costly, but also more informative assessments in order to decide at the end of the process which subset of those are the highest priority for clinical attention. And so you could imagine that at the first stage, you do the kinds of predictive modeling that I was just talking about. At the second stage, perhaps it's more costly in an individual's time and intrusiveness, but maybe you get them to interact online with an avatar, or do a survey, or do other information gathering steps to get an idea of what's going on with them without a human clinician in the loop. Maybe some subset of those gets passed on for review to have somebody who is not the end state clinician, but somebody in the middle, review these things and say, okay, this is the evidence I've got. These are the ones who need the most immediate attention, and so forth. Now, I need to emphasize that within this kind of setting, we are envisioning doing this with people who are already being cared for. And therefore, at any step in the process, you still have the ability, in fact, the need, to receive conventional care on conventional schedules. That's the line that you have across the top here. So people are still seeing their clinicians in a regularly scheduled way. They're still going ahead and able to call them when they need them and so forth. The idea here is that this is a way of utilizing limited resources in order to add information that might not have been available before, in order to improve what's going on with that patient in between when they are calling their doctor, or in between their regular clinical visits, and so forth. So this is an approach that's underway, and something we're going to be continuing to develop in the future, informed by this scenario, this idea of a prioritization framework. So let me leave you with a couple of takeaways. Takeaway number one is that mental health care is healthcare. It is an enormous problem right up there. People often don't think about it, along with the huge problems that we face in the healthcare system. Things like cancer and chronic diseases, cardiovascular diseases, all the rest of that. But mental health care is right up there with those by any way of measuring things, whether you're talking about the economic cost, whether you're talking about the human cost. A second takeaway is that language contains really valuable signal. Language in the clinical records Yes, I haven't talked much about that here in this talk, but also language that people use in their everyday life to which we have greater and greater access thanks to the ability to look at what they are saying on social media. And here, along with this takeaway, I have to emphasize that there are deep ethical issues that need to be grappled with in order to figure out appropriate ways to improve things. And this is something that there's an entire sub-community emerging on that is involved in ethical considerations and discussions like that. Third, I want to emphasize that we need prioritization, not just binary classification tasks. We need to be thinking about the then what question. What is it that happens when technology enters the broader mental health ecosystem? What impacts is that going to have? And given the severe resource limitations that we are likely to continue seeing onward into the future, this creates a set of computational problems that can be viewed as resource allocation and optimization and constrained optimization problems of various kinds. And finally, in terms of using data ethically and making progress so that more people are okay with sharing their data and more organizations are okay with researchers using data for purposes of this kind, I want to leave you with the suggestion that data enclaves are a potentially really useful, interesting way to enable that kind of work to go on while keeping the data privacy issues and all of the other ethical issues of governance and so forth very firmly in mind. I'd like to thank my collaborators over quite a few years. I'd like to thank a variety of sources here for financial support, and I'd like to thank you very much for listening.